Hello, and welcome to the Night Sky Tour for April 2025. I'm Adam from the Wellington Astronomical Society, and tonight we're going to be looking at what we can see in the night sky, the moon phases, and the planets. We'll do a night sky stellarium tour, and then we're going to have a little astronomy lesson about brightness measurement and how we measure the brightness of objects in the night sky. Let's get started. So here are our moon phases. On the 1st of April, we are almost in a new moon. We've got first quarter on the 5th, full on the 13th, and then on the 21st we've got last quarter, and then we have a new moon on the 28th. This means the beginning and the end of the month are going to be the best times for doing deep sky observations. Looking at the planets, at the moment we've got Jupiter low in the western sky. That's going to be disappearing from our evening sky along with Orion as the month progresses. As with last month, we still have Mars in the northern sky in the early evening, and that's going to be setting at around 1 a.m. or midnight when the clocks go back. It's also temporarily turning the duo of bright stars in Gemini, which are Pollux and Castor, into a trio. We've got Saturn, Venus and Mercury appearing in the early morning later in the month, along with Neptune making an appearance with them as well. Let's have a look at those planets and our deep sky objects in our night sky stellarium tour. Here we are at 9 p.m. on the evening of the 1st of April. We've got Jupiter low on the northwestern horizon, sitting directly underneath Orion, slowly sinking into the western horizon as the month progresses. It's still a good target for binoculars at the moment, though. If we zoom into Jupiter, as I showed last month, you can see we've got all of those lovely Galilean moons surrounding it, which are easy to see through a small telescope or through binoculars. In the northern sky, we have Mars, temporarily in the constellation of Gemini, lending it a little extra sparkle. Advancing to the 25th of the month, in the early morning, 5 a.m., we have a little parade of planets going on here, along with the toenail moon. Venus is here, looking bright as usual. Then we've also got Saturn and Mercury. But you can also see that if we zoom in, this beautiful tiny little blue dot sitting there at magnitude 8, so a very, very dim target, none other than Neptune. If you manage to see that, it's an achievement. Let's jump back to the beginning of the month and take a look at some deep sky objects. So it's 10 p.m. on the 1st, and we're looking directly north. There is no moon. Looking up, we can see the two brightest stars in the night sky. Overhead, Sirius at magnitude minus 1.5 and Canopus at magnitude minus 0.6. You'll see them easily overhead even in a light polluted area. In terms of the constellations we've got, let's turn the constellations on. Over on the eastern horizon, we've got our autumn constellations rising Leo, Virgo, Libra, and Scorpius. As the month progresses, they will rise 4 minutes earlier each night. If we swing our view to the south, quite high up, we have the constellation Carina here. And then in this area, we have the Eta Carina Nebula. Let's have a quick look at that. Turn off all these constellations. There's our nebula. This is one of the brightest deep sky targets you can look at. At the moment, it's in prime viewing position high in the southern sky. You'll spot it under a dark sky when there's no moon through binoculars, although you won't see any color in it. You'll just see the shape of it as kind of a grey cloud. We've got a fantastic photograph of that that's been taken over several nights at our Cretny Observatory. The more you go into this image, the more detail it reveals. Advancing towards the end of the month, and if you're prepared to stay up a little bit late, we have the M3 star cluster sitting low on the eastern horizon. We're at 9 p.m. on the 25th at the moment. This star cluster is around half the size of the full moon. It's a magnitude 6 object, so it's rather dim even under a dark sky, making it a telescope or binocular target. For reference, the outer circle is the size approximately of the field of view of 10 by 50 binoculars. As we advance the evening, you can see that if we wait until around 11 p.m. to midnight, it will be high in the northern sky. This continues from the star clusters I pointed out last month. It's a good one to view during April and May. M3 is in fact the very first item in the Messier catalogue that was actually discovered by Charles Messier himself. Messier being the French astronomer Charles Messier, who catalogued many deep sky objects from his observatory in Paris. This was the first one that he actually discovered. Talking about magnitude, I thought it might be worthwhile just to have a short lesson here for those of us who may be new to the subject. Magnitude is how we measure the brightness of things in the night sky. You'd have heard me talking about magnitude a bit in the presentation, and this is because, obviously, items in the night sky can vary in brightness, and so we need a standard way to measure it. So, enter the magnitude scale. This is a scale which is centered on 0. So the idea is the lower the number, the brighter the object. So something at -5 is brighter than something at 0, for example. It's calibrated so that each step is around 2.5 times the brightness of the previous, making it a logarithmic scale. What this means, effectively, is that 5 steps equals 100 times brighter or dimmer. So a magnitude 5 object is 100 times dimmer than a magnitude 0 object. You get the picture. So what's the reference? What did we base this on? The magnitude scale, when it was invented, was based on the star Vega. That's the reference star, and that is magnitude 0. For reference, the midday sun is magnitude -26.7. That is the brightest object in our night sky, and SPF 30 is strongly recommended. The full moon, which is the second brightest object in our night sky, is at magnitude -13. And as you can see, that is the brightest safe magnitude for vampires. Venus, at its brightest, is -5. And then Sirius, which is the brightest star in the night sky, is at -1.5. Vega, as I mentioned, is at 0. And then most of the stars that you can see are in the range between 0 and 5. Under a proper dark sky, and if you've got good eyesight, you should be able to see down to magnitude 6. Through the binoculars we recommend, 10 by 50 size, under a dark sky with no moon, you should be able to see down to about magnitude 9 or 10. Moon phase and light pollution will affect that, but for those curious and interested, the limit of the James Webb Space Telescope is 34. So that's the dimmest object we can actually observe with the technology that we have at the moment. In the Night Sky Bulletin, I usually limit my viewing recommendations down to a maximum of magnitude 8, so you stand a chance of seeing it. Anyway, that's a wrap for this month, and thanks for viewing.